We have, first of all, we've got a function given to us, exponential. Looking for the question. Here's the question mark. How much time is needed between injections? So we're looking for time in hours. We look for that first. Then we can kind of read over the number of milligrams, DH. So this is the answer to this is going to be in milligrams, not time. A certain drug is in a patient's bloodstream H hours, so we're solving, we want to get H. After the drug is injected, it's given by this function. When the number of milligrams reaches 17, the drug is injected again. So how long before we're going to inject again? So that is going to give us 17 is 17 milligrams in the blood system equals the function. And incidentally, this is going down by 15% per hour. That's the rate there. That's what that rate means. But we just need to solve for H, okay, and round it to the nearest tenth. Again, using the graphing calculator, we can graph both sides of these, find the intersection, and we're as good as gold. So let's go with that method. 17 is on the left side, and 45 second E, that's a shifted log, to the minus 0.15. X is our variable that we can use. Okay, and so we're going to graph this. We'll do a standard view, and that means, remember, it's going from -10 to +10. So as long as the solution is within 10 hours, that's it's all going to work. If not, we'll have to change our window a little bit. And we don't see much. Well, what's the problem? So 17 is a y value, and we're only going up to 10. So first of all, we do need the y values to go much higher. We're starting at 45. That's what that 45 is. So what we'll do with our window is we're going to move our window, the top of our window, our y maximum, we're going to move it up to 50 so we can basically see everything. Just to be on the safe side, I'm going to make my x max a little bit more. Let's go for, let's say 24 hours, right? If you wanted to, you could make your x minimum 0 and your y minimum 0 as well, because you're not going to run out, but just leave it as is. And this time we do see the solution here within our window. Notice we're going up to 50. The drug is coming out of the blood, is being used up, and then we get a new injection at the intersection point so that it doesn't go down, stays in there. And this is, I don't know what this drug is for, but our body needs it for some reason. Second calc, what we do is we go to the intersect. And again, it jumps onto one of these. It's on Y1, and yes, that's one of the graphs I want, so I hit enter. It jumps over to Y2, and I second curve, a question. I say yes by hitting enter. And then for the guess, I'm just going to hit enter, and it jumps to the point, and here is our answer. There will be 17 milligrams in the blood system after 6.5 hours, right? Rounding to the nearest tenth of an hour, 6.5 hours. So there's our answer. Here, we just enter that in. How else would we go about solving this? Well, if you, again, I'd recommend getting a graphing calculator, but to solve it by hand, we would divide both sides by 45. That gives us 17 over 45. Now, I'm not actually going to input this, although it would give us to one decimal place, because it says do not round any intermediate calculation. So we want to keep that as is. E to the minus 0.15h. And what we're going to want to do is change this to a logarithm. By doing that, we will, so the log dance, we've got a base to an exponent equals this. So E is the natural log, which is ln, or log base E. The exponent is now going to become the answer. and the input is this 17/45 over here. That was what I call the log dance. It's not really a calculation, it's just moving things where they need to. And remembering that Ln is log base E. Okay, so that's when we have a base like that. Now all we have to do is divide by 0.15. Negative 0.15 cancels. So H is going to be equal to this. We do have a calculator given to us here, so let's just kind of pull that up for the time being. And if I can, again, if you had a graphing calculator, you probably have already used it. Let me see if I can, here we go, get some room here. So I would do natural log of 17 divided by 45. I want to get outside of that, and I want to divide by negative 0.15 and equals 6.48, rounded to 6.5. Same answer, just need all these properties to do that. Either way will work.